In this video, we're going to finally learn what a radian is. So a radian is another way to measure angles. Now, if you think about it, angle measurements are pretty arbitrary. Like, who decided that that was 180? It's just a kind of a weird number. I can tell you the reason they did do it. It's because 360, it's really easy to divide that by a lot of different numbers. So that's why angles are measured up to 360, because you can split them into halves, thirds, quarters, fifths, sixths, like very easily. Same reason there's 60 minutes in an hour as well. But it's not really a great way to measure angles mathematically. I don't want to get into why now, but radians make maths much cleaner, much cleaner. And it's basically very impractical to do it without radians from now on. So how do we convert to radians? This thing here would be 90 degrees. Now, you got to think of it like a circle with a radius of 1. And sort of intuitively, if you think about two angles and you've got like this angle here versus this angle here, you would say that this one is bigger. And you'd almost say that it's bigger because the little green line which is measuring the angle is longer than the little other green line. So it literally is that length that is the measurement in radians. So here, we set the length of the circle to be 1, and that length is the measurement in radians. Now, usually on a circle, the circumference is 2 pi r. If we have a circle with a radius of r and a circumference of c. So if we want this as a quarter of a circle, or the length is going to be the whole circumference times, it's a quarter, but where that comes from is we got 90 degrees out of the full 360. So that's where that comes from. And the radius is 1. And that fraction's a quarter. So the whole length is going to be 2 pi over 4, or if you want to be really fancy, pi over 2. Now, the length of this one, this is 70 degrees here. We can also work out the total length of this in radians. So length is 2 pi r times 70 out of 360. So the length is going to be, well, the radius is 1. So we're going to get 140 pi on the top and 360 on the bottom. And then we can pretty much just try and simplify that fraction down. I'm not great at simplifying fractions, but if you look at 140 over 360 in a calculator and convert it back, it's 7 over 18. So this is 7 pi over 18. And importantly, we can get an approximate for that. So if I look at 7 times pi and divide it by 18, then our approximate's going to be 1.22. So if we look at 70 degrees, that equals, well, roughly 1.22 radians. And that exact number was 7 pi over 18. So the radians is literally just the length there. Also back here, if we had 90 degrees, that equals pi over 2 radians. Now, radians normally has a little c there to show you that it's radians. We don't put a c if it's the pi over 2. Like you could, but when you have pi in the angle, you sort of imply that you're working in radians, so you don't need the units. Okay, so that was degrees, and that is radians. Now, I don't want you to actually do these link calculations every time. It's very easy to do the conversions. So degrees to radians. So for example, if I had 90 degrees, I would have to times that by pi over 180. And that would give me pi over 2 radians. So you don't have to draw a picture each time. 180 degrees, this is pi radians. So that there is pi, half a circle. So for example, 2 pi there is the whole way around. It's a little bit awkward that it's 2. But if this was a circle with a radius of 1, then the circumference is 2 pi times 1, so 2 pi. So that's why. if we're looking at 270 degrees, that's sort of pi and a half, so 3 pi over 2 radians, or it's like 1.5 lots of pi, because that one would be coming around 3/4 of a turn. Okay, converting back, pi over 3. What you can do is you can just use that conversion thing that I showed you before. So we could go pi over 3 times, and then you times it by 180 over pi. So that gets it back to what you need it to be. So 60 degrees. So that is going back on this conversion table. That's timesing by 180 over pi. I should also mention that something like 360 degrees there, you can absolutely use your conversion table. So pi over 180 is what you times it by to get into radians, and we can see that it is 2 pi, like what I said. 7 pi over 6, so if we want to do that, 7 pi over 6 times it by, and then like 180 over pi. That should get us back into degrees. It's 210. So it would look something like that. And then 100, well, we can just convert that across. So you're going to get 100 times pi all over 180, just like that. So you get 5 pi over 9. So that's how you convert between degrees and radians. If you've got a nasty number like 213 degrees into radians, all you need to do is do 213 times and then go pi over 180. So it's 71 pi over 60. Now, usually if it's that nasty, we just go for a decimal approximation. So that's 3.72. 3.72 radians. So radians has a little c there. All right, 1.3 radians into degrees. So you're going to get 1.3 and times it by 180 over pi, and we'll see what we get there. So 74.5. Degrees. Okay, so that's good. What I also want to point out is just some really common ones. So something like 45 degrees, that's going to be pi over 4 radians. Something like 90 degrees is going to be pi over 2. Something like 180 degrees is going to be pi. 270 degrees is going to be 3 pi over 2. And 360 degrees is going to be 2 pi. So just remember those like key values there, and then you can sort of combine them. Like if you've got 135 degrees, well, that's sort of like 3 pi over 4, right? It's like 3/4 of the way towards being a straight line. And that would look sort of like that. But you should be able to get very quick at converting between degrees and radians, because we're about to see a lot of conversions between degrees and radians.